right, we're going to take a look at how to turn a right triangle here into a rhombus. And this was a Regents question from the January Regents of 2025. So first thing we're going to look at is make sure when we are graphing our polygons that we include our letters and our coordinates. As you can see here in the Regents, it'll say state the coordinates of n. So we want to make sure that we actually state the coordinates as well. So it's important to get in the habit of graphing with our letters and also our coordinates just to play it safe. Okay, so we've got our polygon, PET. We want to prove that our polygon is a right triangle. So we know what we're going to need here, and we can see very clearly when we look at it, okay, this looks like a right angle. So what we need to show here is that perpendicular lines have opposite reciprocal slopes. Okay, on the back of your sheet, you have a little bit of a guide here to kind of help you out. But what we're looking at here is what is the slope of P to E here. So if I take a look here, what is the rise? So it looks like it's rising 4, and then the run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so the rise of that is going to be 4, and then the run is going to be 12. So if we simplify that, that slope will be 1/3, and then go ahead and lock it in. All right, so now we're looking for a slope of -3 because we have an opposite reciprocal slope. So if I go ahead and look at this, I'm going down 1, 2, 3, 4, 5, 6, right 1, 2. All right, so the change in the y is down 6, right 2. Simplified will be -3. Lock it in, and there we go. You can say perpendicular lines have opposite reciprocal slopes. Okay, therefore, triangle PET is a right triangle. Okay, so the next thing we're going to kind of look at is what happens if we adjust the shape to kind of form another shape, right? So if we look over here, it's going to say state the coordinates of n, the image of P, after a 180-degree rotation about the center of 1, 3. So you can see I've got 1, 3 right here. One thing you can do is you can use patty paper, and once you use your patty paper, make sure you hold your pen down right here, and then go ahead and then rotate this 180 degrees, and you'll land on your point. Okay. Another way to think about it is if I'm trying to prove that our new quadrilateral here is a rectangle, I know that we're going to have the same distant sides on the opposites and the same slopes on the opposites. Okay. So one way to look at it here is I know that if I'm going to go from here, 1, 2, 3, 4, 5, 6, right 1, 2, I know that I'm going to have to do the same thing down here. So down 1, 2, 3, 4, 5, 6, right 1, 2, and I'm going to land on that point right there. Okay. Another way to look at it is how do you get to the center if I'm rotating 180 degrees? All right, so how do I get to the center of rotation? 1, 2, 3, 4, 5, 6, 7, down 1. And then do the same thing. Down 1, right 1, 2, 4, 5, 6, 7. You see both times I'm going to land on the same exact spot if you're not using patty paper or really thin graph paper. So the point that I found here is our new point N, and I have to state the coordinates, and the coordinates are 8, 2. So very important that we state our coordinates. So what we have now here is we're going to complete our new shape, and we're going to determine, is our new shape a rectangle, right? And now a rectangle is a quadrilateral with 4 right angles. So what do we have here? We already have the slopes of PE. We already calculated that, right? Our slope of PE we said was 1/3, and then our slope of PT was -3. So we need to find 2 more slopes, okay? So the slope of EN, right? So if I'm going from E to N, I'm going right 1, 2, down 1, 2, 3, 4, 5, 6, right? So if I count that, I'm going to say the slope is down 6. So I've got a slope of -6 and I'm right 2, and there we go, -3. Lock that in, and then lock that in, okay? And then we're gonna see, well, what is our slope from E to T? So I'm going over here, I'm sorry, N to T, right? N to T. What is my slope from N to T here? N to T. So if I'm going over here, I'm going down 1, 2, 3, 4, right, 1, 2, or left, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You've got 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, up, 1, 2, 3, 4. All right, so we're going right 12, up 4. So the change in the Y would be 12, the the change in the right would be a positive 4, and then the run would be 12. Simplified would be 1/3. Lock that in and lock that in. So now we can say a bunch of things here, okay? We can say that PE is perpendicular to PT, so that's one right angle. We can say PT is perpendicular to NT. There's another right angle. We can say that EN is perpendicular, if we go up here, EN is perpendicular to NT. And then our last one, we've got PE. Where is our last one? PT to PE. Do we have that yet? Yep. PT to NT. PT to NT. We've got it. So we need PE to EN as our last one. So PE is perpendicular to EN. Therefore, quadrilateral. PENT is a rectangle. Okay, there you go, y'all. All right, have a positive day.